Okay, so students, let us continue with our chapter 2, class 10, acids, bases and salts. Okay, we will discuss today in this portion video 6, 45 and 47 question numbers on your tuition note. There you will find pH scale and what is pH. We're going to combine these two to understand them together because it is easier to understand them combined rather than separate. So you also write with me here. Just draw a line here, okay, a line sufficiently long and not so long, but like that, and then you mark here a point, and let us say this point represents a cup, 1 liter cup containing pure water and a hydrogen ion concentration or hydronium ion concentration. These two are same, so we will write like that. These two here, hydrogen or hydronium ion concentration of this cup is, let us say, 10 to the power 0 moles per liter, the first cup. And there is another cup here, let us say, and the gap should be equal. Here on the line, this represents the same size of cup, 1 liter of water exactly, and here the hydrogen ion concentration is, let us say, 10 to the power minus 1 moles per liter. So you can take one more if you like, another cup of the same size, 1 liter of water, and that is dissolved 10 to the power minus 2 moles per liter of what? Of hydrogen ion or hydronium. So these moles represent the hydrogen or hydronium ion amount or concentration in the cup. Liter here represents the water amount, 1 liter of water. So this is what we have. Now below this you can draw a line, okay, long enough, full notebook with your pencil, scale or pen also is okay, directly. Now let us go to question 47. So question 47 says, what is pH? Now before we go there, let us just find out the pH. So we know the definition of pH is negative logarithm of the hydrogen ion concentration in a solution to the base 10. You may or may not fully understand, but just memorize it. pH is the negative log of hydrogen ion concentration to the base 10. So here we have to know some basic log rules. So just write here log rules on your tuition copy. Okay, so not all, but two basic rules are required to calculate this pH. So the first rule is, if we have here log m to the power n to the base 10, the first log rule is the power here, m to the power n means something like 2 to the power 3. M is like 2 and n is like 3, the power. In such case, the power n comes from, okay, and then the rest is same log m is the base. In an exponent, the lower number is called the base and the upper number is called the power or exponent. So the exponent or power come front and this portion remains same, log m to the base 10. So here n has gone front. That's the first log rule. So let us apply a situation to understand that. Now here, you can take any one of these two, 10 to the power 0 minus 1 or 10 to the power minus 2. Let us take the first one, minus log, and hydrogen ion concentration here is 10 to the power 0. So I'll just put here 10 to the power 0. And the base is 10. So just let us keep it like that. Now let us apply this rule here. M to the power n means here 10 to the power 0. So 0 is like the n. So bring the n front means 0 front will bring 0 into, okay, 0 into, and the remaining is same. So here minus, here log, and here 10 to the base 10. This portion 0 has come front, just like the power n has come front. So here we have 0 into minus log 10 to the base 10. The next log rule that we need to know is this one, second rule, log 10 to the base 10. Okay, how many zeros are here in this 10? Yes, 1, that's right. And so the value of log 10 to the base 10 will be 1. Next here, likewise, log 100 to the base 10. The base is 10, the number is 100, 2 zeros, so here also 2. So likewise, 1000 means 10 to the power 3 will be, value will be 3. So apply that to this one. How much will you get? 0 into minus should be there. Log 10 to the base 10, you know, is 1, so replace it by 1. And you know that 0 multiplied to any number is 0. No sign plus or minus, so 0 doesn't have sign. So this complicated hydrogen ion concentration 10 to the power 0 moles per liter, which we may understand as science students, is converted to a simple number of 0 on this scale. So this is called your pH scale, the simple number 1. This is the actual hydrogen ion concentration, the real concentration, changed to simple number 0. Then if you apply another one, here let us say we apply pH is equal to log hydrogen ion concentration. Let us take this one, then 10 to the power minus 2. Then applying the base 10, applying this formula, log hydrogen ion concentration to the base 10 minus, so negative should be there, negative logarithm. So let us do that, minus log. So here the power, applying the first rule, power is minus 2, so that minus 2 will come from into, and here minus log, the remaining is same, 10 to the base 10. So you have here minus 2 into minus, again, so rather minus, this is bracket, so into, log 10 to the base 10 we know by formula is 1, so we write here 1. The minus and the minus is plus, so 2 ones are 2, plus 2. So 10 to the power minus 2 moles per liter, the actual hydrogen ion concentration has been converted to a simple number called 2 by using pH formula. So like that, and so without calculating also you know that if you apply this formula again, this will be 1 like that. So like that, scientists made a scale like this, 10 to the power 0 moles per liter of hydrogen as 0, if the concentration is, and this one 1, 10 to the power minus 3 will be, like that they made a scale. So let me make it shorter. So here like this, 1, 2 representing this one, equal gappings, 3, like that they made a simple scale of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, like that. So the pH scale runs from usually 0 to highest 14. It can go more than 14, it can go below 0 also, but the normal pH scale is from 0 to 14. So you now know that this represents 9 represents hydrogen actual hydrogen ion concentration of 10 to the power minus 9 moles per liter. We know now, right? So like that, converting the actual hydrogen ion concentration to simple numbers 0, 1, 2, 3 like this is called a pH scale. Okay? Why did they do this? Because this way, even farmers, the uneducated farmers, can use the pH scale to measure the pH of their soil. And then pH is 3, oh, mangoes will grow better there. pH is 9, oh, onion will grow. So like that, they can assess the soil and put the right kind of crops into the different type of soils. But they are going to find it difficult to use this 10 to the power 0 moles per liter like that, no, of hydrogen ion concentration. So that has been converted to simple numbers by using pH formula. So that one scale, simple one, is called pH scale. Okay, and pH is simply the negative logarithm of hydrogen ion concentration. So we have discussed 45 and 47. Okay, now before we go, let us go to question 50. On your tuition note, you will find something. So let us remember this. Now when a solution has pH exactly equal to 7, okay, pH exactly equal to 7, that solution is neutral. The word neutral means the solution is not acid also, not base also. Then anything higher above 7, then that substance or solution will be surely basic. Basic means it's a base. And anything below 7, 6.9, 6.653, the lower it goes below 7, it will be below, okay, let us write it here, below 7 pH is always acid or acidic. Okay, and pH exactly equal to 7 is neutral, as I said, and pH below 7 is definitely acidic. Remember that. Now go to question number 50 and you'll find there a question saying, so we can write there pH equal to 7 is neutral. On your notebook you can write pH below, below 7 is acidic, and then above 7 is basic. Now if you go and read question number 50 or your tuition note yourself, you will understand it yourself. Okay, let us just keep this one for some time, and then before we go here, I've wrapped it up, but H plus and then here H3O plus. Any of these two means the same thing. This is the 10 to the power 0 moles per liter of hydrogen ion. Moles is the hydrogen ion, liter is the amount of water in the cup. Okay, so let us now, before we wrap up the scales, we'll go and see 49. Now there is a question on your tuition note that reads like this, and let us do this here. So here, below the thing that you've written, you write question number 49 on your note, and here solutions A, B, C has pH values 4, 5, and 6. Okay, so that means here 4, 5, and 6. So there will be a cup here, 10 to the power minus 4 moles per liter. 4, 5 here, 10 to the power minus 5 moles per liter. Before it was converted to 5, you know the actual concentration would be 10 to the power minus 5 moles per liter. And here another cup, 10 to the power minus 6 moles per liter. So here we have here a situation like that, 10 to the power minus 4. Okay, let me write properly, minus 4. Now the question is asking which of these three solutions have the highest hydrogen ion concentration, highest amount of hydrogen ion concentration. Now at one glance, which one do you think it is? Yes, normally we'll think 10 to the power minus 6 to have more hydrogen ion concentration. We think like that. But let us see here. Here, you take 10 to the power minus 4 moles per liter, write down, moles per liter. Now let us forget about this mole part and deal with this number. Now 10 to the power minus 4 means 1 divided by 10 to the power plus 4, meaning itu numerator as well. So denominator and power minus 4 to plus 4 is over. So 10 to the power minus 4 can be written as 1 by 10 to the power 4. So it 1 by 10 to the power 4 क्या है? 10 to the power 4 means 1, 2, 3, 4 zeros. And we know that the decimal, when you divide by 10, 100 powers of 10, like 10, 100,000, then decimal move to left. Now where's the decimal on the numerator? No decimal means behind the 1 is there. So it will go 1, 2, 3, 4 places to the left. So starting from here, 1 it will jump, 2 it will jump, okay, 1, 2, 3, and 4, and it will come here. So this is 0.00001 moles per liter hydrogen ion. Okay, the first one. Then the second one, pH 5 means the concentration is 10 to the power minus 5. So 10 to the power minus 5 moles per liter. Just do this, you'll understand. So here, 10 to the power minus 5 likewise is 1 divided by 10 to the power plus 5, right? So that will be equal to 1 divided by 5 zeros. 1, 2, 3, 4, 5 zeros. As I said here, 1, 2, 3, 4 zeros. So decimal has jumped 4 places to the left. When you multiply, it moves right. But when you divide by 10, 100, decimal moves left. So 1 from here it jumped, now 1 left. 1, 2, 3, 4. Now, this time jumped from here. 1, 2, 3, 4, and 5. Now, by common sense also we know this is much smaller than this one. 0.0001 mole is bigger than 0.00001. This is a smaller concentration. So, we can see that as the number is going higher, 10 to the power minus 5, negative power is higher, then actual concentration is actually lower. So, which one do you think has the highest hydrogen ion concentration? Yes, that's right. 10 to the power 4 will have the highest hydrogen ion. As the pH is lesser, the amount of hydrogen ion or hydronium ion concentration will be higher. You can clearly see that. So your answer for this is, which of them have the highest? 4. 4 is the A, right? So here, this one. Remember that. So the higher the pH, the lesser the hydronium ion concentration or hydrogen ion concentration. The lower the pH, the higher the hydronium ion concentration. So we have completed 45, 47, 49. We will now go to the next question, 54 and 50 also we have discussed, 54 and 55. So let us do that, and that will end the portion for 2C. After that you can give your test. So question number 54 says differentiate, okay, differentiate, I'll combine, differentiate, okay, let me do it like this to make it easy. Differentiate 54 says between, okay, differentiate between strong and weak acids. Strong and weak acids. What is the difference? And question number 55 says between strong and weak bases. So we will deal with these two questions before we go on. Now, to make it easy to understand, let us take one by one here. So let us take question number 54. So here, let us take an acid, very common acid. Okay, just below, a little bit gap here, you write hydrochloric acid. That's a very common acid. So right there, HCl, okay. Then you put an AQ here, because acids will release the hydrogen ion only in water. We learned that in our previous classes. So when you dissolve in water, you know acids always break down into the ions. The first ion is very common, hydrogen ion. You know that from your starter also, H plus and Cl minus are there. So H plus is the hydrogen ion swimming in water, and the chloride ion. So this is the chloride ion. Now it will release like that. Now let us take another acid which is of a different kind. Let us say keep some gap here and write here. Acetic acid. Formula for acetic acid is CH-2 COOH. Dissolve it in water like you did for the first. So both are acids, okay? Now when you dissolve in water, it will break up into the positive and negative ions, cations and anions. So the cation here, the anion here is CH-2 COO minus. You know this from your starter itself, acetate ion. So this is the anion. Plus, here H is always positive, so H plus, that is the hydrogen ion. So this is AQ at the back, so that you know it's dissolved in water. So here, this is your hydrogen ion. Now you know very clearly both of these are acids because both are releasing hydrogen ion. Any substance capable of releasing hydrogen ion in water, definitely an acid, we know. But what is the difference between these two? Okay, just remove the arrow once. The difference is this. Here, in the second case, put reversible sign. That means half arrow pointing right and left. Okay? Now, what does that mean? This means that the acetic acid, when you dissolve in water, they do break up into the acetate ion and the hydrogen ion. But the breaking down is not complete. When a certain amount of acetate and the hydrogen ion are formed, it stops, and then after some time, these two will begin to combine and change back to the left direction. Also means changing back to the full acetic acid molecule. That means complete dissociation or breaking of this acid to the ions is not possible. Means everything of the acetic acid do not completely break down into the ions. That's why they are called weak. Those kind of acids are called weak acids. That means those acids, in other words, that release lesser ions compared to other acids are called weak acids. But in the first case, you see the arrow is pointing only one side, which means when you put hydrogen chloride gas dissolve in water, this will completely break down into hydrogen ion and chloride ion, and the reaction doesn't move left. Means everything will break down after some time into hydrogen ion and chloride ion, and there will be no HCl molecule left. That means complete breakdown takes place. Those type of acids which release more ions freely are called strong acids. So your textbook defines in a slightly different way, but many textbooks define it as when an acid breaks down completely into ions, they are called strong acids. When an acid partially or do not completely break down into ions, they are called weak acids. But your textbook says those acids which release more ions in water than the other acids are called strong acids, which is also correct. Okay, I hope you understood this. So question number 54. Let us see question number 55 now. 55 is the bases, strong and weak bases. Let us take, for example, sodium hydroxide. Now keep some gap here, write the name. This is good to write this one, sodium hydroxide. Okay, sodium hydroxide is a base, NaOH. Now dissolve this in water, means AQ at the back. Now what happens is, interestingly, it completely breaks down into the ions. You know the ions will be, from the formula itself you can see here, sodium ion here. And the next one, OH, means, you know, keep same line and below the plus, hydroxide ion, right? So we know this is Na plus in AQ and OH minus dissolve in water. So you'll get these two positive and negative ions, and it completely breaks down into these ions. So it is a strong base. Now let us take here an example, 55, continuing. Next year, 55, let us say we took ammonium chloride, ammonium hydroxide. Just write there ammonium hydroxide, okay? Ammonium hydroxide. Just above that, make the formula yourself by remembering your starter. Yes, ammonium ion is NH4 plus, hydroxide ion is OH1 minus, so 1 and 1 shift, no need to write. When you dissolve in water, arrow, half arrow right, half arrow left. That means it will break down into what ions? Yes, that's right, ammonium ion, right? And then slightly above, here on the same lines, put and slightly below the arrow, the other one you can very clearly see is it will release hydroxide ion. So definitely it's a base because it's releasing hydroxide ion. Here also, see, any substance that release hydroxide ion are called bases. Any substance that release hydrogen ion are called acids. Now here, you can write here ammonium ion, you know, NH4 plus, and then hydroxide ion OH minus, both dissolve in water. But interestingly, you see here that after some time, these two stop breaking down, and in fact, these two combine and slightly change back to this, and this continue to change to this. But there is no stage where this one completely break down into ions. Some part of ammonium hydroxide, the whole gutta molecule is remaining unbroken. So they do not break up completely. So these are ammonium hydroxide is a weak base, remember that. Sodium hydroxide is a strong base, remember that. Hydrochloric acid is a strong base because they completely break down. Then what is acetic acid is a weak acid, okay? So this concludes question 54 and 55, difference between strong and weak bases. After this, if you go and read on your tuition note, question number 46, okay? Question 46, 48, 51, 52, okay, you can write it down, 52 and 53. These are so easy, you can understand it yourself now, so do it by self, okay? Do self by self, okay? Or read by yourself, you will understand it. Okay, so this ends the video 6, and after this you can take your test 2C, I think. Okay, so okay, thank you.